We'll wait for just one more minute and start. Yeah, I think 9 of them have only joined. So we'll just start the class. Actually, today's topic is a very important topic. That is a module 4 that is regarding the test techniques. Everyone able to hear me and able to see my screen, right? Okay, thank you for confirming. So we'll start. So anyone know what is test techniques?
Equivalence, partitioning, decision table.
Sorry, Maria.
Bound. Test techniques are the techniques that we apply to acceptance criteria to so that we can derive test cases that will cover that will have the best coverage. Example of test techniques are uh, equivalent class partitioning, then boundary value analysis, state transition, decision table, error result.
Okay, that's correct, Maria. Yes. So, Maria, that was very correct. So, actually, these test techniques we use is like we derive test cases by adopting these test techniques. Okay, so in order to test some application, we have to adopt these test techniques in order to derive the test cases. So that is a use of the test techniques. So the overview, that is the purpose is to identify the test condition. Any doubts, anyone? I think Deepa, you are unmuted. Okay. Now the purpose is to identify the test condition, the test data, and the test cases. Okay, that is the main purpose of the test techniques. And there are basically three, the whole module, it is divided into three parts basically. The black box, white box, experience-based and collaboration-based test approaches. So here, the more important topics here are more weightage topics are black box and white box testing techniques. Okay. So coming to why the choosing the test technique. Okay. So why we are choosing the test technique? How we have to choose a test technique for a particular application. So the main things we have to consider is the component of the system complexity. So component of system complexity means if it is a banking application, suppose, so the system will be more complex. So such type of test techniques should be adopted for such complex applications. So if it is just a e-commerce site, so that may not be that much complex as a banking. So so depending upon the complexity of the application, we have to choose the test techniques. Now, regulatory standards, there may be some regulatory standards like ISO standards, etc. So in order to meet such standards, we have to adopt some other kind of test techniques. Now, customer or contractual requirements. So, customer or contractual requirements means there may be some customer requirements. Based on the customer requirements, we have to test that application. So, these are the way. These are how we are choosing the test techniques. Okay. Now, the risk levels, risk type, and the test objectives, available documentation. Available documentation means, for example, a e-commerce site. So we may be having a already available documentation for that. So based on that experience and the already available things, we can choose a test technique based on that. So based on the experience and all, we can choose the test techniques. Now, tester knowledge and skills. Then based on the available tools in the market and time and budget, we choose the test techniques. Now, then the software development lifecycle model. So this model you'll be learning in the further sessions detail. So then you will know more about it. Then the expected use of the software. How is the expected working of the software? Based on that, we choose a test technique. Then the previous experience with using test techniques on component or system to be tested. Then the types of defects expected in the component or system. Okay, so based on the defects and based on the previous experience, etc., we choose the test technique. So these are all general terms. You can go through this and you can understand it. Now, coming to the main portion, that is the black box technique or the behavioral technique. So this is the first type of test technique. Okay, this black box itself means it is opaque. We can't see the inside of that, right? For a black box. So it concentrates only on the input and the output of the test object. So it doesn't refer to any of the internal structure. For example, we won't be executing any code, or we won't be going inside the code level testing. Okay, only we will be considering the input and output. That is expected results only we will be considering. What is some input data will be providing, some outputs will be getting. So we'll be only concentrating on the input and output of that test object. We won't be referring to the internal structure or the coding portion. Okay. Now the test bases include the formal requirement documents, specification, use cases, user stories, or business processes. So we make use of the formal documents, different documents, like yesterday we had mentioned, some documents like business documents, specifications, user stories, or business processes. These we will be making use of. These test bases we will be making use of in order to do the black box testing. Okay, we never include a code. Okay, coding is not a code level check is not done in black box testing. Only the input and output we are concentrating on the black box testing. Okay, there are 5 types of black box testing techniques. That is equivalent partitioning, boundary value analysis, decision table testing, state transition testing, and use case testing. So these are the 5 types of black box testing techniques. Okay, so black box is the main heading and the 5 types are under the black box testing. So out of this, the major importance is given for the first 3, that is equivalence, boundary, and decision table. So from these 3, many questions will come. It has more weightage, but state transition and use case testing are also important. We have to go through that also. We can't skip anything. So most of the questions comes from the above 3 of them. Okay, equivalence, boundary, and decision table testing. So till now, is it clear? What is black box testing? You got an idea? Any doubts?
Yes,
Okay, thank you. Now next we will move on to before explaining what is equivalence, what is boundary value and all, we will just go through the characteristics of the black box testing techniques. Okay. Here, as we have mentioned, the test cases. So these test cases and test conditions and test data we are deriving from the test basis. So this test basis, what does this include? The test basis includes the requirements, the specification, use cases and user stories. So from these use cases, user stories and requirements, we derive the test cases and test conditions. Okay, for the black box testing. That is the characteristics of black box testing. So test cases may be used to detect gaps between the requirements and the implementation of the requirements, as well as deviation from the requirements. Okay. So test cases detects gaps between the requirements. That means what? So we will be having some requirements, right? So when we that is the when the implementation is done, after the implementation is done, we will be matching it with the requirements, like so each test case has to be mapped to the requirements so that we can detect the gaps between that requirements and the implementations. Okay, so that is what is meant by test cases may be used to detect gaps between the requirements and the implementation of the requirements. Okay, so when you map all the requirements, each and every requirement with a particular test case, it is easier to detect the gaps between the requirements and the actual implementation of those requirements. Now, the coverage is measured based on the items tested in the test basis and the technique applied to the test basis. For example, we have derived from after I am using a test technique and I am deriving 10 test cases. Okay, out of this 10 test case, I have executed 5 test cases. Okay, so what will be my coverage? It will be the number of test cases executed, that is 5, divided by total number of test cases, that is 5 by 10. So 50% will be my coverage. So that is the definition of coverage. Got it? Is it clear? Any doubts? Okay. We'll move on to the first test technique. That is first test technique in black box testing. That is equivalence partitioning. So now you can see this diagram, right? In the diagram, we have from 10 a.m. to 10 p.m. Okay. So here we have two things. From the diagram, we can understand there are two types of partitions, valid partitions and invalid partitions. So now here, there is no specified endpoints are mentioned. That is a starting point and ending point. Nothing is mentioned here. But from the diagram, we can understand that 10 a.m. and 10 p.m. are the two boundary values here. So before that is before 10 a.m. is considered as invalid partition, and after 10 p.m. is also considered as an invalid partition. So in equivalence partition, what we do is like we will divide our range into different partitions, like valid and invalid partitions. So if for now here we are considering 10 a.m. to 10 p.m. as a range. So inside the 10, that is in between 10 a.m. and 10 p.m. we will be having some values, right? There are some 3 partitions they have given. So that these 3 partitions will be valid partitions, and beyond that will be invalid partitions. Here it is clear from the diagram, right? So between this 10 a.m. and 10 p.m., now they have split it as 3 partitions. That depends upon the tester, whether we have to split it as 3 partitions or whether we can split it in any way. It is not compulsory that we can split it in different. We have to just split it in these 3 partitions only. That valid partitions can vary. Okay, got it right? This what is equivalence partitioning. So there are 2 types of partitioning, valid and invalid partitioning. That is explained here. Got it? We will see more examples in the coming forward slides and more questions we will work out, so it will be more clear to you. Okay. Now till now, no doubts, right?
Ma'am, does that partition needs to be equal means so the partition that we have done here needs between 10 a.m. 10 p.m. like that the division there.
No, no, it is no, it need not be equal. You mean like that is 10 a.m. and 10 p.m. Like you mean like
Like for example, if it's between the numbers 50 to 10 to 100, then it should be like 20, 10 to 20, 20 to 30, like that.
no,
That
no. It is that depends upon the tester. It can be you can do what if it is between 10 to 20, 10 to 50, then you can do like 10 to 30, 30 to 50. That alone can be enough. Or you can
can
say
can
10
we do it like 10 to 30 and 30 to 10
30
to
to
40, then 40 to 50, like that, two
yes,
partition?
and
Is
two
that
parts.
also possible?
That is also possible. That is also possible. So there is no compulsion that we need to follow some intervals or anything like that. That depends upon the tester. Anyway, we can do, but some valid partitions also we have to test, and we have to make sure that we test the invalid partitions also individually. Only make sure that we test the we cover in our test case, we cover the valid partitions and invalid partitions also. The range and everything, it can be different based on the tester's approach. Clear, right, Maria?
Yes, ma'am.
Okay, thank you. Then, yes. Now we'll go through the theory portion. That is, partitions are called, these partitions we have mentioned in the diagram, right? They are called as equivalence classes. And the valid values, partition that contain valid values is called valid equivalence partition, and partition that contain invalid value is called invalid equivalence partition. And each value must belong to one and only one equivalence partition. And any partition must be divided into subpartition if needed. So each value should belong to only one equivalence partition. Okay. So if we are partitioning like this, it can be like 10 to 5 p.m., 10 a.m. to 5 p.m. So in between 10 a.m. and 5 p.m., you can consider one equivalence part, one valid value. Then 5 p.m. to 9 p.m., you can consider another valid value, like that way. Okay. Then any partition must be divided into subpartitions if needed. So if you need subpartitions, then you can divide it into subpartitions if it is required. Now, the coverage is defined as the number of equivalence partitions tested by at least one value divided by total number of identified equivalence partition. Okay. So in this diagram, there are 5 partitions. So I have tested only 2 partitions. So what will be the coverage here? So there are total 5 partitions, and I have tested only 2 partitions out of this. So what will be the coverage? As we have mentioned.
2 by 5.
Yes, 2 by 5. Correct, Aishwarya. Yes, 2 by 5 will be the coverage. So that is how we calculate the coverage. Now, invalid partition should be tested individually. So you have to make sure that you test the invalid partitions also. Okay. Now, consider this example. A mobile number will only accept 10 digits. So the valid case will be the 10 digits. And the invalid case will be the digits less than 10 and digits greater than 10. So there will be 2 invalid partitions and 1 valid partition. Okay. In this case. Now we'll move on to a question. one of the fields of a form contains a text box that accepts numeric values. So the numeric value ranges from 18 to 25. So you have to identify the invalid equivalence class values. So invalid means what? It is 18 to 25 is a range given. So invalid values will be less than 18 and greater than 25. So that will be the invalid value. So what will be the invalid equivalence class values here? Yes, A. 17 will be the correct answer. Okay, correct. Adina Muhammad, correct. Yes. So everyone has got it, I think. So 17 is the correct value. Now, next question. Any doubts in between, please ask. Now it's okay, right? Now next question. One of the fields of a form contains a text box that accepts only alphanumeric values. Identify the valid equivalence class value. So it is accepting alphanumeric values only. So in the question it is asked to identify the valid equivalence value. So valid class value should contain alphanumerics. Yes, C is the correct answer. Yes. So C contains the alphanumeric B, O, 0, K. So alphanumeric. Yes. Everyone, it is okay, right? C is the correct answer. Anyone has any doubt in this? Alphanumeric concept. Got it, right? Okay. Now, yes. Next question. The switch is switched off once the temperature falls below 18. Okay. When the temperature is below 18, switch is off. And then it is turned on when the temperature is more than 21. So more than 21, switch is on. Okay. So the valid cases will be below 18 and above 21. Okay. Identify the equivalence classes which belong to the same class. Okay, so what will be the equivalence class that belong to same class? So values below 18 will be valid and more than 21 will be valid. But it should come under the same equivalence class also. Kartika, yes, A is not the correct answer. Yes, there are mixed opinions here. So below 18 we can consider this first option we can consider one by one options 12, 16 and 22. Those 12 and 16 are below 18. Okay, that comes under one class. But 22 is more than 21. So that comes under another class, right? So these are in different classes, but they are equivalence values, but they belongs to different class. Now, 24, 27, 17. 24 and 27 are more than 21. So that is correct. But 17 belongs to a different class. That is below 18 class. So they are also different class. Now 22, 23, 24. So they are as the temperature is more than 21. So they all comes under the same class, right? 22, 23 and 24. So C will be the correct answer. So is it clear? We had mixed opinions here. So Kartika and yes, it is clear, right? Everyone. Devi, it is clear, right? Why C is the correct answer? Okay.
Yes, ma'am.
Okay, thank you. Now next question. In the examination, a candidate has to score minimum of 24 marks. Okay, now it is a score of a score in an examination, score of a candidate. So minimum score is 24 in order to clear the exam. The maximum marks that he can score is 40. Okay, identify the valid equivalence values if student clears the exam. So the range is from 24 to 40. So you have to identify the valid equivalence values. Yes, C is the yes, C is the correct answer. Okay, so everyone got it right. It is clear, right? Okay. Now we'll move on to next analysis, that is boundary value analysis. So boundary value analysis is also very similar to equivalence partitioning, but here we are considering only these four values. In the equivalence partition, we used to consider that range, right? So valid partitions, but here in the boundary value, we consider only these four values. That is the lower boundary, upper boundary, and lower boundary minus 1 and upper boundary plus 1. These four values only we consider for the boundary value analysis. Now, so boundary value analysis is an extension of the equivalence partitioning. It can be applied only when the partitions are ordered and we know the minimum and the maximum value. So if we know the lower boundary and upper boundary only, we can calculate lower boundary minus 1 and upper boundary plus 1, right? So the important thing is that we should know the minimum and maximum value of a partition. And it can be used at all test levels, mainly used to test a range of numbers. Now, some variations include 3 boundary values before, at, and just over the boundary. So this is not as a ISTQB standard. Here, in some kind of testing, we consider like LB minus 1, we consider LB plus 1 and UB minus 1 values also. So there are 3 boundary value conditions, but that is not a ISTQB standard. Sometimes this is also considered, but it is not a, but in the question and all, mostly only these this way you have to calculate. If anything specific is given only, you need to go in this manner. Otherwise, boundary value analysis questions comes up means you have to consider only these four values. Okay. Now, boundary coverage is measured as the number of boundary value tested divided by total number of identified boundary values. So, out of these boundary values, there are four values right here. So out of this 4, I have tested the four values. Then it will be 100% coverage. So out of the 4, I have tested 2 means it will be 50% coverage. Got that coverage thing, right? So this is the coverage, boundary value coverage. Now, system will accept numbers between 10 to 25. So what are the boundary values in this case? 10 and 25 we have to consider. And we have to consider the formula, like what was the formula? LB minus 1 and UB plus 1. So it will be 10 minus 1 and 25 plus 1. So 9, 10, 25 and 26. So these will be the boundary values. Is it clear? Any doubts? Yes, Namita. Thank you. Maria, thank you. Okay. Now we will move on to the next slide. Yes, now we'll be moving to the questions. A text field of an okay, what is that, Deepa? Should I explain this once more? Okay, so boundary value means, okay, yes, boundary value here, this one, this you have doubt this accept or the boundary value I need. Okay, I'll explain boundary value once more. Boundary value analysis, in here we consider the lower bound, upper bound, and lower bound -1 and upper bound +1. So these are the 4 values that we consider normally in boundary value analysis, and it is an extension of the equivalence partition. So the main thing we have to understand here is, if we are given the maximum and minimum values only, we can apply this boundary value analysis. Okay, so maximum and minimum value should be given to us. Then only we can calculate this lower bound -1 and upper bound +1. And in this case, the coverage comes like the number of boundary values tested divided by the total number of boundary values. So if out of these 4, I am testing the entire 4 boundary values, means it will be 100% coverage. So as this example says, 10 to 25 numbers the system is accepting. So what will be the boundary values we will have to test? We have to consider 10, 25, then 10 -1 and 25 +1. So these will be the boundary values that we need to consider. Is it clear, Deepa? Okay, thank you. No. Okay, now we move on to the question. A text field of an application accepts input as the age of the user. Okay, here the value allowed to be accepted by the field is in between 18 to 30. So the upper boundary and lower boundary are given, inclusive of both the values. By applying boundary value analysis, what is minimum number of test cases required for maximum coverage? Yes, it is correct. D is the correct answer. So how it comes? That is 18 to 30. So lower bound and upper bound is given. 18 is the lower bound and 30 is the upper bound. So lower bound -1, that is 17, then 18, then 30, then upper bound +1, 31. So 17, 18, 30, 31. So these 4 are the boundary values. So for maximum coverage, we have to test these 4 values, right? So 4 by 4. So that will give the 100% coverage. So that will be, so the option will be D. That is 4 test cases are required for the maximum coverage. Everyone, it is clear, right? Can I proceed to the next question? Okay. Okay. Now, okay. Next question. A text field. Okay, this is what we discussed. No. A text field is in an application accepts input as the age of the user. Here the value. Okay. Here the value allowed to be accepted by the field is between 18 to 30 years, inclusive of both values based on boundary value analysis. Which of the given consists of valid collection of boundary values? Okay, here valid collection of boundary values they have asked. Yes, the same question only. C is the correct answer. That means that that we have already explained, right? That is 17, 18, 30, 31. You can apply the formula to both the lower bound and upper bound and see the result. Okay. So that is clear, I think. Now, next question. Next question is a mix of boundary value analysis and equivalence classes. Okay. We can consider the question, that is, order number on a stock control system can range between 10,000 and 5 nines inclusive. Which of the following inputs might be a result of designing tests for valid equivalence classes and valid boundaries? Okay, so here we have to consider the valid boundaries and valid equivalence classes. So it is a combination of both equivalence class and boundary value analysis. So how will you do that? Okay. Deepa, Devi, okay, you're telling E. Namita is telling C. So we'll check it. So 10,000 and 9 fives. So we will consider first the boundary values. Okay. So 10,000 minus 1. That will be that will be 4 nines, right? Yes, 4 nines. And this one will be 5. I will just put in the chat the values, the numbers. That is 10,000 minus 1. That will be 9999. Okay. Then 10,000. Then we have 999. Three nines and 1 followed by 6 zeros. Okay. So these are the, so you can see in the chat I have put the values. So these are the boundary values. We can say that. Okay. So out of this, so we got the valid boundaries. Now valid equivalence classes. So any value that is less than 10,000 and any value that is outside this 999 will be considered as invalid equivalence classes, right? So we can consider only values which are only the valid partitions also, because they have mentioned valid equivalence classes. So we can consider only the values between this 10,000 and 999. So we can, so it is told that the range that they have inclusive, they have told. So we can consider 10,000 and yes, 5 nines and the value between that range. So it will be some 5,000, 50,000. So C is the correct answer. Got it? I think Anu, you have missed that 0 and 9. Okay, everyone got it right. E is not the answer because it becomes invalid. That range 999, we are here considering the valid boundaries, it is correct, but it won't become a valid equivalence class. Any values before 10,000 and any values above this five nines is invalid partition. So we can't consider that as valid equivalence classes. Everyone, it is clear, right? C is the correct answer. Okay. Can I move on to the next one? Okay. Okay. I think now we can move on to the next thing, that is. So now the equivalence classes and boundary values is completed. Now it is about the decision table testing. Okay. Decision table testing means you have different many combinations you have to test. Okay. For such purposes, we use the decision table testing. For example, you can consider this table itself. So you have some conditions. The conditions are username and password. And you have the different actions here. So rule 1, rule 2, rule 3, rule 4. So in the rule 1, we'll be mentioning like if the username you have entered is false and the password is false. Okay. Both are wrong values. Then it will show the error message. If username is correct and password is wrong, then it will again show an error message. When a username is wrong and password is true, then it will give again an error message. But both are true means it will return the home page. Okay. So this is why, this is how when we use this type of decision table testing. Okay. That is when we have different combinations to test. Okay. So decision tables are a good way to record complex business rules that a system must implement. Okay. When creating decision tables, the tester identifies conditions, often inputs and resulting actions of the system. That is, the inputs that we have mentioned as the conditions, and the actions are the outcomes. Okay, what will be the outcome when we give this inputs, that we will be mentioning in different rule tables. Okay, so that is what mentioned here. The test identifies the condition of an inputs and the resulting actions of an outputs of the system, and these form the rows of the table, usually with the conditions at the top and the actions at the bottom. So this is the decision table testing. The value of the condition and the actions are usually shown as Boolean discrete values or range of numbers. Okay. Now, it is possible to delete columns with impossible combinations of conditions or conditions that do not affect the outcome. Okay, so we can delete the columns. Okay, we can delete the invalid columns. If you think that this is not a valid test case, then you can delete that column. Okay. So that if some impossible conditions you are testing, then you can delete those columns also from the decision table. Now, coverage is measured as the number of decision rules tested by at least one test case divided by the total number of decision rules. So here we have 4 rules. Okay, out of which we have tested only 2 rules. So what will be the coverage? So what will be the coverage here? There are total 4 rules. We have tested only 2 rules here. So what will be the coverage here? Yes, 2 by 4. That is 50% coverage. Yes, Muhammad. Yes, Namita. Yes, everyone. Correct. Yes. So you got what is decision table testing, right? So in order to, if we have some complex rules and all, and many combinations we have to test, we can use this decision table testing. Okay. So when we go through a scenario, you will understand it more clearly. That is, here we can go through this example. So what is expected result for each of the following test cases? Okay. So expected result you have to pick up from here. So classify the scenarios. Above, there are four scenarios given here. You have to classify them as valid or invalid. Okay. Now, we can go through one by one. A 43-year-old in insurance class C, premium is 100 and excess is 1000. So 43-year-old will come in which rule? Rule number 3. Okay, in rule 3, it is age limit 30 to 50. So 30 to 50, inside that 43 will come. So 43 in rule 3 it has come. So they have mentioned like their premium is 100 and excess is 1000. But when you go through this, premium is what? 70 and excess is 500. So this is a invalid scenario, right? This first one is an invalid scenario. Now, similarly, second one, anyone can say whether it is valid or invalid. 51-year-old, insurance class C.
Invalid.
Yes, 51 is invalid. Yes, 51. So 51 comes in the greater than 50 years. Insurance class is C, that is correct, but the premium and excess are wrong. Now, C, option C, 31-year-old. Is it valid or invalid?
Invalid.
Okay, 31, yes, we will go through that. That is 31. It comes under rule 3. Insurance class is B, that is correct. And premium is 70, but excess it is 2,500, but it is 500. So that is invalid. Now the last one, 23-year-old. Yes, D is valid. Yes, 23-year-old is between 21 and 29. Yes. A is the insurance class. That is correct. Premium is 90 and excess is 2,500. So this is out of the four, last option is valid. Okay. It is clear, right? For everyone. Okay, Arya, Kartika, yes, you are correct. Yes, Anu, yes. Okay. Now next we move on to the next question, that is, which of the following black box testing technique focus on covering all combinations of triggering conditions? All combinations of triggering conditions. Yes, D is the correct answer. Yes, decision table testing. So it covers all the combinations, right? So that is the decision table testing. Now, next is state transition testing. So transition is initiated by an event. So state transition, here we have to mainly understand the difference between a state transition diagram and a transition table. Okay. So the state transition diagram shows the possible software states, how the software enters, exits, and transitions between the states. Okay. And the state transition table shows all the valid and invalid transitions between the states. That's very important. State transition table shows all the valid and invalid transitions. Okay. But state transition diagram only includes valid transitions. It excludes invalid transitions. Okay. Coverage will be like number of identified states or transition tested divided by total number of identified states or transition in the test object. So we will see one diagram here. So the first diagram shows a valid transition. It's a simple diagram like ice to water, water to vapor, then the reverse transition. So this only shows a valid transition. But you see the second diagram, it shows the invalid transition. So if you are considering it as a state transition diagram, which one of them is a correct state transition diagram? First one or the second one? Yes, first one, right? Because why is it so? Because we have told that state transition diagram shows only valid transition. It excludes invalid transition. For the second diagram, there is an invalid transition. So it is a wrong state transition diagram. So if it was a state transition table, then we could have included valid or invalid or any kind of transitions we could have included. Okay, we can see a similar question, how it comes up as a question. That is based on the given state transition diagram of a switch. Which of the following test case is invalid? So you can look into the options and say, yes, Kartika, yes, Muhammad, it is correct. C, Adina, yes. Kartika and Vidya, okay. So I will say, tell one thing, that is, we can just look into this options and say how it becomes valid or invalid. Off to on, it can be a valid one. On to off can also be a valid scenario. But fault to on, it is not a valid one, right? It is something invalid. But on to fault can be possible. So these three are valid. Option C is invalid. Okay. Okay. So the transition on to off to on is mentioned here, and on to fault is also mentioned here. So one that is not mentioned is fault to on in the state transition diagram. So state transition diagram consists of only valid transitions. So this C, invalid transition, is not mentioned in the state transition diagram. So that is the correct answer, option C. Everyone, is it okay? Are you able to follow this? Okay, Vidya. Okay, thank you for confirming. Okay. Anyone in between, any doubts are there? Just let me know. Okay. Okay, thank you. Now, next one. Okay. State transition diagrams involves valid and invalid transitions. Is it true or false? It is false. Yes. Now, next is use case testing. Use case testing actually is the interaction between the user and system. Okay, so we will consider here a scenario of inserting a card. Okay, so the main success scenario, A as actor and S as a system. So A inserts the card, then validates, as though the system validates the card and asks for a pin. So the actor, that is a person who is using that. Okay, if you are the user. So he enters the pin. Then the system validates the pin. Then the system allows access to the account. So there can be many scenarios, right? And these are the extensions. Extensions are the negative conditions. So first is the main success scenario is this. Yes, it is validating the pin, and the pin you have entered is correct, and it validates and you are allowed to access your account. But the extensions, the negative scenarios, you can term it as if the card is not valid. So it should display some message and it should be rejected. The system should reject the card. So if the pin is not valid, then also it should display some error message and ask for a retry twice. Now, if the pin is invalid for 3 times, then it should eat the card and exit. So that will be the negative extensions. Okay. So this is what is meant by use case. This is how we make a use case testing. Okay. So it is based on the characters, human, system, etc. and subjects. Subjects is system to which the use case is applied. So actors means what? This end user can also be different people, right? So if I am a normal user, I am inserting the card and taking money withdrawal is my purpose, means I am the end user. If it is from the banking people, they are trying to insert money or do some manipulation. So they can be there the system behaves in a different way. Okay. So that is meant by it will be based on the actors and the system in which that is a use case is applied, it works. Okay. Each use case specifies some behavior the subject performs in collaboration with one or more of its actors. Okay, that is what I mentioned now. So the system behavior can vary based on the actors. Actors means the users. So if it is a normal person who want to withdraw money, then he can do that. So if it is from some system admin or someone from the banking banking people, banking officials, they have to access the system, it will behave in a different way for them. So that is based on the actors, the behavior changes. Use case can include possible variations of its basic behavior, exceptional behavior, and error handling. Okay, tests are designed to excise the defined behaviors. Coverage can be defined by the percentage of use case behavior tested divided by the total number of use case behaviors. That is similar to all those we have discussed, the coverage. Okay. Now, use case testing involves the following behavior: basic behavior, exceptional behavior, error handling, for all of the above. So what is the option? Yes, 4 is the correct answer. Yes. So that is mentioned in this sentence itself. That is, use case can include possible variations of its basic behavior, exception behavior, and error handling. So it's clear, right? Now we will, okay. Is it clear? Till now it is clear what is black box testing and the main techniques in black box testing. It's clear, right? Okay. Okay, thank you for confirming. Now, white box testing techniques. Now we are going to deal with structural technique or white box testing technique. So white box means it is transparent. So you can see the structure of the test object. So that means it includes code. So the test base includes code, software architecture, and detailed design. So there are two types, statement testing and decision testing. So the main difference between white box and black box is like white box includes the internal structure. Okay, the code level things is included in the white box testing. Black box testing includes the input and output. We concentrate on only the results and the inputs. Okay, so basically we as testers, we normally do black box testing, and mostly the white box testing is done by the developing team. Now there are two types, that is statement testing and decision testing. Okay, so similar to the black box testing, here we will discuss the characteristics of white box testing technique also. The test condition, test cases, and test data are derived from test bases that may include code, software architecture, detailed design, or other software or the source of information regarding the structure of the software. So what we had mentioned in black box testing, in black box testing, we used to derive these test cases from the test basis that includes requirement documents, business specifications, user stories, and all. But here, the test basis is code, architecture, and the more about the structure of the software. Okay, that is the difference. Now, the coverage is all same. That is, it is measured on the based on the items tested within a selected structure. That is a code or interface, and the technique applied to the test basis. Coverage definition is all the same here also. Now, coming on to the statement testing. So here the main important two things are there, statement testing and decision testing. So in statement testing, we consider the nodes. Okay, statements or nodes in the code. So here, going through the flow chart. So first in the flow chart, we can see some black boxes right here, A, B, A greater than B, A, and if B. So these black boxes are called the nodes. And these green lines are called the branches. Okay, branch. So in this statement testing, we concentrate only on the nodes or the statements. Okay, got it? Now I'll explain more in the other this slide. That the statement coverage is the minimum number of paths for covering all the nodes. So we consider only that black boxes. Any way we do, so in any number of paths, that is a minimum number of paths which is required to cover all the nodes. Okay, so what are the minimum number of paths? Considering this example, what is the minimum number of paths to cover all these nodes, all these black boxes? Can anyone say? Yes, 2, 1, Muhammad 2. Okay. Okay, I'll explain it. So it should cover all these black boxes. So directly A greater than B, A and if. So this path will cover all these black boxes. But B is not covered, right? In this path, B is not covered. So in order to cover B, we have to go through this path. So minimum number of paths will be 2 here. Okay. This path and this path. So the minimum number of paths for covering all the nodes, we used for statement testing. Is it clear? Yes, Karthik, Aishwari, yes, it is correct. Anita, it's clear, right? Okay, thank you. Okay, so everyone, you are all on the same page. So all of you agree that it is the minimum number of paths is 2 here. Now we'll move on to the next question. So determine the statement coverage for the below scenario. So you can do that. So it should be the minimum number of paths. Okay. If in a single path you can cover all the node, means there can be answer can be 1. So if it requires more paths, then it should be more. Okay, like that way. So you can work on this question. How many paths are required? So minimum, that is determine the statement coverage for the below scenario. So how many paths are required here? Okay, 3, 3. Yes, 3. Everyone, I think it is, they have mentioned 3. Vipin, Nitin and all, it is clear, right?
Yes, yes.
Okay. Okay, so 3, everyone agree, right? So how come it is 3? So this is one path. So this covers these nodes. But I can see like this path. So this covers another. And here, but these two got missing. So this will cover the third path. So 3 paths for covering all these nodes. Got it? So one thing I have to tell, like, okay. Okay. Now next question. After this, I will say that. Okay. Now this question, try to answer this one. How many paths are required? So different opinions are coming to one, 3. Okay. Okay. So I will stress on the word once more. It is a minimum number of paths covering all these nodes. Okay. So here you can we can do the analysis. That is, from here it starts say greater than 0, 8 to print and end. So in this one path, in single path, we covered all the nodes, right? So that is the only a single path is required. So Deepa, is it clear? Anita, Namita and all, is it clear now? A single path is only required. By this, we cover. Okay, thank you all. So, within a single path, we cover all this. Okay. Now, next question for the statement coverage. How many paths are required in this case? Yes, I think now everyone are on the same page. Yes, 2. Yes, Vipin, yes. Okay. Yes, that is the correct answer. 2 is the correct answer. Devi, yes, correct it is. Okay. So 2 is the correct answer. So how it is covered? This one, this path. By this path, you can cover all these nodes except this print. So the next path will be this one. This entire thing we can cover. So the 2 paths are required for. So consider the word minimum number of paths and you have to cover all the nodes also. So that is the statement testing. Now, next question. Yes. Next, how many paths are required? Newcomers are able to understand, right? Arya, I forgot some of the names. I think Muhammad, able to understand, right? Nitin, uh, okay, Arya, yes, thank you for confirming. Okay. Anu has mentioned one, yes. Devi, two, yes. No, okay. So, okay. Okay, now all have mentioned two. Yes, Anu, it is actually two. Anita has mentioned three. Okay. So now we will check that if there is confusion. So how many, that is minimum number of path and max and all the nodes covered. That is our aim. So here what we'll do is, here in this single go we can cover all this, right? Okay. Here we can cover like this, print, then coming here and doing like this. You can cover all the nodes. So this path and this path we can cover. So two paths. By the two paths we can cover all these nodes. Is it clear, Anita and Anita? Okay. Anu, is it clear? You have mentioned one path.
Can you repeat once more?
Okay, I'll repeat it once more. The two paths are here. That is here by in this single path we can cover only these, but these nodes will be missing. So in order to cover these two print nodes, we can do like this. Go like this and go like this and to end. Okay. So within two paths, that is minimum path we have to choose. So there may be many paths to cover these nodes, but minimum number of paths will be this one. So is it clear?
Yeah.
Okay, thank you. Okay, now, yes, now the shortcut. Now, actually, in the examination, sometimes the flowchart will be given like this, or sometimes the algorithm will be given like this. Okay, so from the algorithm, mostly algorithm will be given. From the algorithm, you have to draw this flowchart and you have to find out in this manner, number of nodes covered like that. So if you if there is any limitation in time, so if you couldn't draw this algorithm and see, so if there are any limitations, or if you have by mistake your flow chart is incorrect or anything happens, so in order to shorten the time also, we can use these shortcuts, okay, for deriving the answers. Okay. So for the statement coverage, before that you have to understand what is a if, a nested if and unnested if. So nested if means, first we'll discuss what is an unnested if, then we'll discuss what is a nested if. So if, else and end if. Okay, so this if else ending here. And this before starting the next if there is a end if. Then it is a unnested if. Unnested if statements. Is it clear? So before starting the next if, there is end if, then it is a unnested if. Okay. In this case, it is a unnested if and it has else statements also. But in this case, what happens? Before starting this if statement or before starting this if statements, there is no end if, right? So this is a nested if statement. Okay, is it clear? The difference between nested if and unnested if?
Yes.
Okay, thank you. Okay. So now we move on to the shortcut. A statement coverage percentage equal to number of executed statements divided by total number of statements into 100. Okay. So that is clear, right? Now, statement coverage for nested if. So nested if case we have discussed here, right? Nested if, yes, this is a nested if case. So for nested if and the condition they have given, that is always if it is a nested if, then it will be equal to 1 plus count of else. Okay, 1 plus count of else. 1 plus count of else means it will be like, so how many else statements are there? How many else you can see here? Only one else, right? So 1 plus 1, that is 2. So we have derived the same answer, right? It is 2 paths. We have earlier we have derived the answer by choosing that minimum number of paths, right? This was 2 paths. The answer was 2 paths. So from the formula we now derive, that is for the nested if case, it is 1 plus count of else. 1 plus count of else is in this algorithm. When you see the else, there is only one else. So 1 plus 1, that is 2. Is it clear? So the next one, that is unnested if. In the case of unnested if, that is this case. Unnested if. That is before the statement end if should be there. So in the unnested if cases, it is 1 if there are no else statements. So if there are no else statements, then it is 1. If there is else statement, then what is it? 2. So here you can see there are there are else statements are present in this unnested if case. So the coverage will be 2. So without applying the formula also we had found out like that, right? This is one path and this is another path. So 2. Is it clear? Any confusion? Let me know. Okay, Karthik, Arya, yes. Okay. I think it is clear to everyone. Any doubts? This is a shortcut so that you can reduce your time while doing this problem. So you can, if you by heart this shortcut, you can by seeing the algorithm itself, you can write the answers. You don't have to draw the flow charts. So flowchart method is the best way, but you can use the this shortcut also. So moving on to the next question. For the given fragment of code, following paths or test cases have been executed. What statement coverage is achieved? So in very important thing, statement coverage means always consider the nodes. Nodes means these things A, B, C, D, F, G, H, I. So these are the nodes. So how many nodes are there total? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 nodes in total. Yes, correct, Vidya. 8 nodes are there. Now, what statement coverage is achieved? So here you can consider test 1, it is A, B, C. So 3 nodes are covered here. In test 2, it is covering A, B, D, G, H. But A and B is already covered in test 1. So we can omit that here. So we can give like test 2 covers D, G, H. So the first test covers 3 nodes and the second test covers again 3 nodes. So totally 6 nodes. So 6 divided by 8. That will be 75%. Is it clear? Yes, Aishwarya, correct. 75%. Everyone, is it clear? Yes. Any doubts, please let me know. If I need to explain in Malayalam also, I can do it here. Is it clear, everyone? Got it, right? Okay. Now moving on to the next question. Sorry, not yes. Now decision testing. So now now we are talking about the decision testing. So statement coverage is done. Next is decision testing. So decision testing is focuses on the decisions in the code. So testing is done based on the decision outcome, and it is stronger than the statement coverage. In statement coverage, we were only considering the nodes, right? We were not considering the branches. So it is more stronger than the statement coverage. So 100% decision coverage guarantees 100% statement coverage and not vice versa. Decision coverage is the minimum number of paths to cover all the branches. That is the important thing. In statement coverage, it was minimum number of paths to cover all the nodes or the statements. This is the minimum number of paths to cover all the branches. Decision means branches and statement means nodes. Okay, that should come to your mind. Okay, so we will see here. So all these green lines, okay, these are, so the same examples that we have mentioned in the statement coverage, we are going to see in the decision testing examples, okay. So we will see that the paths might differ in both these cases, okay. So how you can say this? What is the minimum number of test cases required for 100% decision coverage here? You have to consider the branches. So what will be the outcome? Branches are the green lines. Now you just forget about the nodes, that is the black boxes. Now we have to consider all the branches are covered or not. So what will be the number of paths? Yes, 2. Correct. 2 is the number of paths. So 2, how it came? Like it is like the straight path. So these branches are covered. So 1, but in this straight path, this branch is not covered, right? So we have to include one more path. So 2 paths. Okay. Now, what is the same example for decision coverage? How it will be? How many paths it will be? Considering the branches. Yes, correct. 3 only, yes. So I think everyone is on the same pace. So it is a 3 only. So 3 is the correct path. So that it will be like this. This path, then this path, then this one. Then only all these green lines will be covered. Okay, so these are the 3 paths. Okay. So now going in the statement coverage also we had the same result, right? So it may not be always same for the decision and statement, but this has come as a coincidence. Okay. Now we will move on to this one. The next one. Okay. What will be the decision coverage here? Everyone is getting this, right? Different opinions are coming. Okay, yes, Arya, no, yes. The 3 is the correct answer. How it became 3, we will check. How we call test 3. That is 1 means you must have considered all the nodes only. But I have told, right? You have to consider all these green lines. All these green lines should come and it should be the minimum number of paths also. So all the green lines, how you can accommodate. So when you do this single path, it won't accommodate these lines, right? So these two. So we have to consider this, but it won't accommodate this one. So we have to consider this. So 1, 2, and 3. So 3 paths are required to consider all these. 3 paths are required for the full decision coverage. Okay, got it? Is it clear, Anita, Aishwarya, Deepa, and all? Okay. Others also it is clear, right? I'm just mentioning the names because they were telling some different answers. So that's why I'm mentioning the names. So for them and others, it is clear, right? Nitin, Karthik, everyone, it is clear, right? Okay, now we'll move on to the next question. Yes, this one you can answer, 18th question. How many paths? So decision coverage means suddenly the branches should come to your mind. Yes, 4 is the correct answer. Some have given 3. So still there are confusion. I think that is decision coverage means we are thinking about the branches. Okay. So branches means when you consider this path, others are not considered. We can consider like this. That is this entire path we can consider. Okay, 1. So some branches were excluded, right? When we consider this. So we have to consider this 2 and 3 and 4. So 4 paths are required. Okay, so decision coverage and statement coverage, now you can see, right? The answers differ. Is it clear, Anu, Maria and all? How we derive 4? Yes, it is clear, right? Okay. Others, everyone, it is clear, right? Should I explain it once more? Okay. And I'm moving on. Okay, next question. Determine the decision coverage for the below scenario. Decision coverage you can determine it here. You're understanding the difference, right? How the statement coverage and decision coverage, how it is different. In the statement, we were only discussing about these nodes, this black color thing. But in the decision, we are discussing the green colors. Okay. "19", everyone is saying 3 paths. Okay. 2. Again, there are mixed opinions. Okay. Yes, 19, I will say once more. That is, it should cover the branches, but I have told, right, it should be minimum number of paths. In minimum number of paths, all the branches should be covered. So how we can cover it? The straight path, 1. Now, this 1, then this, okay, 2. The second path will be like this. This also covers all these print branches, right? So 1 and this 2. So it is a 2. 2 is a 2 paths. It's the correct answer. Anu, Deepa, Vidya, it's clear, right? 2 is the correct answer. So you have to consider the minimum number of paths also. Okay. Minimum number and to cover all the branches. Okay. I think it is clear for everyone. So here also we have a shortcut for this. That is for nested if and unnested if cases. So if it is a coverage is number of decisions executed by total number of decisions into 100. Now decision coverage for nested if. Nested if case we will see 1. That is equal to 1 plus count of if. There it was else. Now here it is if. So nested if. This is a nested if case. So 1 plus count of if. So how many if statements are there? 1, 2, 3. 1 plus 3, 4. So 4 number of paths. That is what we have derived from the diagram by the flow chart, right? So from the algorithm directly you can use the formula. So 1 plus count of if is for the nested if. For unnested if it is always 2, irrespective of number of if. Okay. Unnested if we can see here. So this is the unnested if case. So it is always 2. Irrespective of count of if, it is always 2. Is it clear? Shortcut is clear, right? Okay. Thank you, Namita Kartika, for confirming. Now, yes. Now, next question. Yes, a similar question. Like for the given fragment of code, paths or test cases have been executed. What decision coverage is achieved? So here, don't consider this A, B, and C. We have to consider this branches, this arrow marks. 1, 2, 3, 4, 5, 6, 7, 8. 8 arrows are totally there. Now, out of this, what is the coverage? For the test 1, it is A, B. So we have to consider this one arrow. Okay. B, C, this arrow. So the second arrow. Okay. Now that second test is again A, B. So that is already covered in the first test. So we can reject that. Now B, D. B, D is another arrow. So we have to consider that. So B, D, 1. Now D, G. D, G is another arrow. That is 2. And G, H is another arrow. That is 3. So 1, 2, 3 and 1, 2. So it will be 2 plus 3, 5. 5 divided by 8. That will be 62%. Everyone, is it clear? B is the correct answer. Yes, Aishwarya, correct. One more time I'll explain. So here we are testing the decision coverage. So decision coverage, what we have to consider? The arrow marks, not the nodes. So total arrow marks you have to count. So divided by that total. Okay. So how much the test 1 has covered? A, B, that is 1 arrow. B, C, that is another arrow. So 2 of them. Here test 1 covered 2. 2 arrows. 2 parts. Okay. Then test 2 it covered A, B. But A, B is already covered in test 1. So we won't take this. We take B, D, G, H. Sorry, B, D, D, G and G, H. So there are 3 arrows. So 3 plus 2, that is 5. 5 divided by 8, it is 62%. Clear, everyone?
Yes.
Okay. Anu, everyone, it is clear, right? Vipin, Arya, everyone, it is clear? Okay. Now we move on to next question. No, sorry, not it is yes. Now next is experience-based techniques. Okay. So experience-based testing is like it is based on the experience of the tester. Okay, tester skill, intuition, and experience with similar applications and technologies. Okay, so that is experience-based testing. So sometimes we don't go through these formal techniques. due to the specifications may be poorly defined and all. So we use this experience-based testing. Okay. So based on the tester's experience and techniques may achieve varying degree of coverage. So if a person is, for example, I am testing a banking application and I have two people, like there is a domain expert and also there is an experienced tester. So the domain expert may be catching more issues and he may be adding more test cases for that particular domain. So he is interested in that, he is experienced in that domain. But an experienced tester, he may be thinking in a general testing perspective. He is not a domain expert, so he might be having a less coverage. So based on the tester skills, the coverage might vary. So the coverage can be difficult to assess here, and it may not be measurable also. So there are three types of this experience-based testing: error guessing, exploratory, and checklist-based testing. Okay. Now, characteristics of experience-based technique. That is, here the test conditions and test cases and test data are derived from a test basis that includes the knowledge and experience of testers, developers, users, and other stakeholders. Okay. So what does the test basis for this include? It includes the knowledge and experience of testers. Okay. And the developers and users. Okay. From their knowledge, we are deriving the test cases and test data. This knowledge and experience includes expected use of software, its environment, likely defects, and the distribution of those defects. Okay, so the knowledge and experience includes the expected use of the system. So how the system, what is the usage of that system, what is the environment for that system, and what are the defects and how that defects are distributed in the system. So if it is a airline application, so airline application means you are doing a booking. So you can book for any cargo or a passenger booking. Different types of booking might be there. So you can say that if you are an experienced hand in that, then you can say that yes, there may be different defects in this particular area. So how that defects will be distributed. So these all things you may know based on your experience. Okay. Error guessing means anticipate the occurrence of mistake, defect, and failures from tester's knowledge. Okay, so like I have already said, like he may be aware about this. That is how the application has worked in the past. So the tester's knowledge on how the application has worked in the past, what type of mistake developers tend to make. So we may know that if it is something related to some revenue related things, your calculation related things. So if there are any modules like that in your application, so you can know that yes, developers, there are chances for them to make more errors in those areas. So you can concentrate on those areas. So that is a type of mistakes that developers can tend to make. These all you can know based on your knowledge and your experience. Okay, the failures that have occurred in other application, like you might be so in one organization you have worked on a similar e-commerce application. Now we have moved on to another application, another team, and here they are also using a e-commerce application. The application may be there, they may be customized for different users, but the underlying principles may be same, right? So based on the failures you have faced in the other application that you've worked already, you can conquer the failures of this application also. Okay. Here we create a list of possible mistakes and design tests that will expose it. Okay. So based on these defects, okay, possible mistakes, what can be the possible mistakes? And you create a list of all these mistakes and design the test cases based on that. Okay. That is the error guessing. Is it clear? So under experience-based testing, based on the experience of the tester, we are deriving the test cases. So these are of 3 times, that is error guessing. Based on the errors, we are finding out the test cases. Then next is the exploratory testing. Till now it is clear, error guessing till now. Okay. So these are all general terms only. You can go. We can go through it, and you can read through it also. It is all general terms, so it is easy to understand also. Now, so this is error guessing. Now next is exploratory testing. So exploratory testing means you explore an application with no predefined test executed or logged or evaluated dynamically during test execution. Okay, that is informal tests are designed, executed and evaluated dynamically during the test execution. Test results are used to create tests for areas that need more testing. Okay. So you find that a certain booking module or adding to cart module or there are different modules, right? So the billing module. So you feel that yes, the test results, we make use of the test result to create the test for areas that need more testing. Okay. So if you feel that yes, there are some missing or incompleteness in some particular modules, then you add more test cases for that. At times it is conducted during session-based testing. Okay, so and it is useful when there is few or inadequate specifications and significant time pressure on testing. Complements other formal testing techniques. That means if we have a that is these executions actually this exploratory testing is actually a time boxed activity. Some 30 to 120 minutes they will be giving and they will be asked to conduct those executions. That is called test sessions. Okay, that is why they have mentioned session based testing. So these time box test executions are actually called as test sessions. So within that test session, you do this exploratory testing. So it is when we do this type of exploratory testing, when there is a time pressure on the testing activities, or when there is some when there is more time pressure, we do this type of testing activity, this exploratory testing. It complements the other formal testing techniques. Now, checklist-based testing. So this, I think we have already discussed that it is based on a checklist that we create during the test analysis of the test basis. Okay, so we create a questionnaire and we identify different modules, sub-modules based on their benefits for the business and for the end user. So like the testers design, implement and execute tests to cover test conditions found in testing. So testers can create new checklist or expand an existing checklist, but should use an existing checklist without modification. So we will be writing down like we won't be writing detailed test cases. We will be writing a checklist. That is, yes, we have to cover this module. We have to cover the login functionality. We have to cover the booking functionality, and we don't write deep, in-depth test cases like click on this, click on that, and the test cases, everything we won't be mentioning. Verify this, so verify whether a booking can be created successfully. So we'll be writing down the checklist only. So and either you can create a new checklist or you can expand on the existing. So there might be some existing checklist available. So you can expand on that also. It turns out to be useful mainly in absence of test cases. So when you don't have much detailed test cases, this checklist is very useful. And it will give rise to variation in testing when the coverage increases and repeatability reduces. So in the test case, if we have more number of other test cases, means that if there are a lot of test cases. So in the test cases, we may have different repeated steps, right? So in the checklist, the repeatability will be less because we are just like verifying these things, right? So we will reduce the repeatability also and the coverage also increases. Is it clear now? Exploratory, error guessing and decision testing and experience-based testing. Is it clear? Any doubts in the session? Okay. Now the question, which of the following is the characteristics of experience-based test technique? Yes, C. Yes, I think everyone has got that. So C is the correct answer. That is, test cases are created based on detailed design information. That is which type of test technique? Test cases are created based on detailed design information. Can anyone say? That is which type of testing? First option. Yes, white box testing, correct. Now, the test items, the second one, items tested within the interface code section and are used to measure coverage. That is which type of testing? Option B, which type of testing it is? Yes, again, white box testing. Now, the test techniques heavily rely on testers' knowledge of the software and the business domain. That is the experience-based testing. And the last one, the test cases are used to identify deviations from requirements. That is which type of testing? Yes, black box testing. Okay. So that is so option C is the correct answer. Now the next question. In your project, there have been a delay in the release of brand new application and the test execution started late. But you have very detailed domain knowledge and good analytical skills. The full list of requirements have not yet been shared with the team, but management is asking for some test results to be presented. So which is the best test technique that will you use in this situation? Yes, it is. Yes, option C. But there are some mixed opinions. Okay, okay. So checklist-based testing. Checklist-based testing. We have here a sentence is mentioned like full list of requirements has not yet been shared. So requirements are not yet been shared means we can't create a checklist. Okay. So requirement should be shared. That should be there. So then only we can go for a checklist based testing. So here we go for a exploratory testing. Okay. Is it clear? Okay. Thank you. Now next question. No, I'm sorry, no, it is not next question. That is collaboration-based test approaches. It is a new portion that is included in the syllabus. So The main focus is on the defect avoidance by collaboration and communication. It includes the following: collaborative user story writing, acceptance test driven development. Okay, so it is collaboration and communication. So all the that is different parties like the stakeholders, the product owners, the developers, testers, everyone will communicate and collaborate and collaboratively write the user story. That is what is called a collaboration based test approach. Okay, it includes collaborative user story writing and acceptance test driven development. So collaborative user story writing. There are three critical aspects called 3Cs. These are the card, conversation, confirmation. Card is a medium describing a user story. So yesterday I have explained about the user story, right? So it is a card is a medium describing a user story. For example, an index card, an entry in the electronic mode. So a card, it will be as a particular registered user, I want to reset the password, something like that. Okay, so that will be the card, that will be the user story. In that card, you can specify the user story. Conversation explains how the software will be used, can be documented or verbal. So then you will make the conversation on that user story. Okay, on how that will work, how the software works and all. Then confirmation. Confirmation will be the acceptance criteria. Okay. The most common format for a user story that yesterday I have mentioned, like as a role. So as a registered user, something like that you can mention. I want the goal to be accomplished. So I want to log into an application so that I can the resulting business so that I can reset my password. So that can be the business requirement. Okay, followed by the acceptance criteria. So acceptance, now, the techniques such as brainstorming and mind mapping, collaborative authorship, good user story should be independent, negotiable, valuable, estimable, and small and testable. So user story should always be tend to be independent user stories. Okay. And negotiable. Negotiable means if you can say like, I want to delete a account. So deleting an account requires creating an account. So that user stories can be dependent. Okay, that should be dependent, right? Once you create an account only, you can delete an account. So, or when you create an account only, you can update an account. So that will be, that type of user stories will be dependent. So that you have to negotiate that, yes, these user stories has to be dependent. Otherwise, you have to make sure that this user story should be independent and it should be valuable. Okay, it should be added and the estimable. Estimable means within the particular time you can, when you are writing complex user stories. Okay, then what happens? The time, the effort required to complete that user story will also be more. So you have to make sure that the user story should be estimable and small and easy to test. Okay. And the perspective involves business development and testing. So all these people collaborate and communicate together for in this collaborative testing type approach. Okay. Now, next is acceptance criteria. So that I have yesterday also I have mentioned that. Yes.
Can you please explain that first point once again?
First point.
Brainstorming.
Brainstorming and mind mapping, collaborative authorship. So these are different techniques by which you write the user stories. So in different organizations, they prefer different methods for writing the user stories. Like as in the cards, they may be writing. So brainstorming and mind mapping means all the people will be sitting together and they will be collaborating and communicating, right? So in the so that is meant by brainstorming and mind mapping. Okay. In order to write the user stories. Is it clear?
Yes.
Okay. Okay. Now next is acceptance criteria. Conditions that an implementation of the user story must meet to be accepted by the stakeholder. So when, okay, these are the conditions that that an implementation of the user story must meet to be accepted by the stakeholder. Okay, so when these conditions are met only, it will be accepted by the stakeholder. So in the implementations, these acceptance criteria should be met, then only that implementation will be accepted by the stakeholders. Okay, acceptance criteria are used to define the scope of the user story, reach consensus among the stakeholders. Then describe both positive and negative scenarios. Serves as a basis for the user story acceptance testing. Allow accurate planning and estimation. So these are all the acceptance criteria. These are the acceptance criteria used for, okay, defining the scope of a user story. Reach consensus means that is effective communication and negotiation skills are very crucial in the process to ensure that all stakeholders feel that their needs are addressed and to achieve the consensus that support the project success. Okay, that is the reach consensus. So describe both positive and negative scenarios. We have to include both positive and negative scenarios in this acceptance criteria. It serves as a basis for the user story acceptance testing. Okay, so once a user story has to be accepted, means if we satisfy this acceptance criteria, so all these acceptance criteria, only a user story will be accepted. Now, allow accurate planning and estimation. Okay. That is, so the ways to write a acceptance criteria. Yesterday I have mentioned like given, when, then format. It is a behavior-driven development format. Okay. That is a scenario-oriented format. That is given, when, then. Then there are rule-oriented formats. Like bullet point verification list or tabulated form of input output mapping. So these are all rule oriented formats. Okay, so there are different formats by which we can write this acceptance criteria, and there can be some customized formats also that different users follow, so that can also be considered as the acceptance criteria, as long as this acceptance criteria are well defined and unambiguous. Okay, any format you can follow, but the main, mostly we follow the given, when, then format. Okay. Now, is it clear this much?
What's that BDD? That's so.
BDD means behavior driven development. Okay, that you will come across in the agile classes, so that you will that will be more clear when you go through that module. Okay, BDD. Okay, that is given, when, then format we use in that type of approach. We use given, when, then formats. Okay, this part of the module is there repeated in another one session also. So there you will get a more understanding. Okay. Is it clear?
Yes.
Okay. Now, acceptance test driven development. Acceptance test driven development is a test first approach. And here we have the following steps. Okay, specification workshop. The specification workshop is we organize a workshop. Okay, at the start of each iteration, we organize a workshop to discuss the examples of stories that are planned for that particular iteration. Okay, transfer of the domain knowledge to developers and testers so that everyone has a shared and common understanding. So in this session, what they do is they discuss on the particular user stories that has to be performed during the particular iteration, and what they do, they will transfer these domain knowledge of the testers and developers with each other, and they will be coming into a shared and common understanding. And the second is the creating the test cases. So the test cases involves both positive, negative, and non-functional quality characteristics. In addition, no two test cases should describe the same characteristics of the user story. Okay, so there should not be any repetition. So to avoid the repetition, we say that there should not be no two test cases that describe the same behavior of the user story. And the test cases may be executed manually or automated. So automation and manual execution both can be done in the for executing a test case. Okay. Now the question, acceptance criteria must cover only positive scenarios. Is it true or false? Is it clear till now? Any doubts? Yes. 80 months. Okay. Okay. 1 minute. Okay. Acceptance test. Start here. Okay. Acceptance test driven development. What we do is like we have it is a test first approach, and we follow these steps. Okay. We first thing is like there is a specification workshop. In the specification workshop, at every start of each iteration is actually a term in agile methodology. Like you can say start of a feature development. Okay. For example, and start of a feature development. So, or a module development, what they do is like there may be different user stories. Okay, for a module. So, if it is a cart module. So cart module is a module. Okay. So and you can consider it as an epic or something like that. Okay. A main thing. So that is what they are going to develop in this phase. So a cart module. So in the cart module, we will be having different user stories. So as a registered user, I should be able to log into the site and I can add these number of items into my cart, and then I can delete an item. So that may be the first user story. Second user story may be deleting items from the cart. Third user story means maybe updating the quantity of the items in the cart. So these may be the three user stories we are considering to develop in that particular module. Okay, consider like that. So first what they will do, there will be a workshop. In the workshop, they will discuss about these user stories. They will create these user stories and discuss on that, and then they discuss on the user stories that they are planning for a particular iteration. And here what happens, different people can say their different opinions. So as a tester perspective, I may be analyzing that. Yes, there can be such a set scenarios, then how the developers will tackle that situation. So this there will be a collaboration and domain knowledge sharing between the developers and testers, and they all come to a common understanding in the specification workshop. And then the test cases will be created. So the test cases will be both positive, negative, and non-functional test cases will be there. And the no two test cases should describe the same characteristics of the user story. So there should not be any repetition of these test cases for a particular user story. Okay. And these test cases may be executed manually or using some automation tools. Is it clear, Arya? Okay, thank you. Then the question is clear, right? Now, next final question. Which of the following statements best describes the acceptance test-driven development approach? Yes, C is the correct answer. Yes, in ATDD, tests are created based on the acceptance criteria to drive the development of the related software. So that is the correct answer. So C is the correct answer. Everyone got this right? Is it clear? So is this topic clear to everyone? So one more clarification I had from yesterday's topic. Yesterday's topic I gave you a wrong answer, I think. So are you able to see my screen now? Success factors for reviews. Is it are you able to see that screen?
No, it is still on collaboration-based test approach.
Okay. So I will just share that. Actually, I made a mistake and later only I realized that. Okay. So this question, that is success factors for reviews. Which of these statements is not a factor that contributes to successful reviews? So yesterday all have given an answer like participants should avoid behaviors that might indicate boredom, exasperation or hostility to other participants. It is mentioned like it is not a factor. Okay, not a factor that contributes to successful reviews. So that option D is the correct one. Failures found should be acknowledged, appreciated, and handled objectively. So why it is not a factor means that is that word failure. So how a failure comes. So we have told like after the dynamic testing phase only, there is if you identify the failures, you identify the failures after the dynamic testing. So whatever things you identify, whatever issues you identify in the static testing phase is a defect. So that defect has turned into a failure in the after the dynamic testing. So that is not a successful review, right? So it should, the failure should not be acknowledged or appreciated or handled. If instead it is that word is defect, defect found should be acknowledged, appreciated, and handled objectively means it would have been correct. But it is failures, so that is not a factor that contribute to the successful review. Okay, option D is the correct one. Everyone, is it clear? So failure is something that occurs after the dynamic testing. So we are talking about the static testing success reviews, right? Successful reviews. Okay, thank you. So just make that correction. So today's topic, is it clear actually, everyone? Actually, this is a problematic module, so that is why I'm asking. So is it clear? That is black box testing, white box testing, and experience-based testing and all. It is not, it is theory portion, but the problems you understood, right? Statement, decision coverage and all. Okay. Okay. So I will send a link for your feedbacks. Where can we find all the same exam account? Yes, it will be included in your study material. They will send you the study material. It will be included in that. All those questions, all those that we have discussed and extra question, practice questions, all those will be provided to you so that you can work out and see. So trying to work out these problems, as I have mentioned, the shortcuts also we have mentioned. So if you don't have time to draw the flow chart and all, you can depend on the depend on this thing, like the shortcuts. So if you have time, go for the flowchart and traverse through the branches and nodes and all, and try to do that. Any doubts, please let me know. So please complete the forms, feedback form. And if you don't have any doubts, you can leave for the day. Thank you.
സ്റ്റേറ്റ്മെന്റ് കവറേജിന്റെ ഒരു പ്രോബ്ലം പറഞ്ഞില്ലായിരുന്നു ലാസ്റ്റ്.
സ്റ്റേറ്റ്മെന്റ് കവറേജിന്റെ
അതെടുക്കാവോ?
എടുക്കാം. ഇതാണോ?
അതെ അതെ.
അത് ഒന്നുകൂടെ പറയാനാണോ?
അതെ അതെ.
സ്റ്റേറ്റ്മെന്റ് കവറേജിൽ നമ്മളിപ്പം നോക്കുമ്പോഴത്തേക്ക് നമ്മൾ നോട്ട്സ് മാത്രം കൺസിഡർ ചെയ്യുന്നത്. അപ്പൊ നോട്ട്സ് എന്ന് പറയുന്നത് ഈ സർക്കിൾ ചെയ്തേക്കുന്ന ABCD അങ്ങനെ 8 നോട്ട്സ് ഉണ്ട് ഇതിനകത്ത്. അപ്പൊ ടോട്ടൽ 8 വന്നു. പിന്നെ ഇതിനകത്ത് ടെസ്റ്റ് 1-നകത്ത് Aയും Bയും Cയും, അതായത് ABC ഈ 3 നോട്ട്സ് ടെസ്റ്റ് ചെയ്തിട്ടുണ്ട്. അടുത്ത ടെസ്റ്റ് 2-നകത്ത് ഇതേപോലെ തന്നെ ABDGH. അപ്പൊ ഇതിനകത്ത് ഓൾറെഡി ടെസ്റ്റ് 1-ൽ Aയും Bയും കവേർഡ് ആണ്. അപ്പൊ പിന്നും അത് നമ്മളിവിടെ റിപ്പീറ്റ് ചെയ്യേണ്ട കാര്യമില്ല. അപ്പൊ Aയും Bയും നമുക്ക് മാറ്റി വയ്ക്കാം. പിന്നെ ബാക്കി ഏതൊക്കെ നോട്ട്സ് ആ ഉള്ളത്? Dയും Gയും Hയും. അപ്പൊ ഇവിടെ ടെസ്റ്റ് 2-ൽ 3 നോട്ട്സും ടെസ്റ്റ് 1-ലും 3 നോട്ട്സ്. അപ്പൊ 3 + 3 6. അപ്പൊ നമ്മൾ ഈ 2 ടെസ്റ്റിനും കൂടെ ചേർത്ത് 6 നോട്ട്സ് കവർ ചെയ്തു. അപ്പൊ 6 ഡിവൈഡഡ് ബൈ ടോട്ടൽ എത്ര നോട്ട്സ് ഉണ്ട്? 8. അപ്പൊ 6 ഡിവൈഡഡ് ബൈ 8 അങ്ങനെയാണ് 75%. പിടികിട്ടിയോ? ഓക്കെ. വേറെ എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടോ? എന്തായാലും ഓക്കെ. ഇതേപോലെ ഡിസിഷനും മനസ്സിലായല്ലോ അല്ലെ? ഡിസിഷനകത്ത് നമ്മൾ ബ്രാഞ്ചസ് ആണ് എടുക്കുന്നത്.
ഡിസിഷന് ബ്രാഞ്ചസും
മറ്റേതിന് നോട്ട്സും. ബ്രാഞ്ച് വരുമ്പോഴത്തേക്ക് നമ്മൾ ഈ B to D എന്നുള്ളത് ഈ ബ്രാഞ്ച് അങ്ങനെ കണ്ടുപിടിക്കും. അത് പറയണോ ഒന്നുകൂടെ?
പാത്തും എടുക്കുന്നത്.
ഇത് പറയാം, ഒന്നുകൂടെ പറയാം. ഇത് ഈവൻ ഡിസിഷൻ ടെസ്റ്റിങ്ങിലാണെങ്കിൽ ഇപ്പം A to B, അപ്പൊ ഈ ആരോകളാണ് നമ്മൾ എണ്ണേണ്ട. അപ്പം ഇവിടെ ആരോ എന്ന് പറഞ്ഞാൽ ടോട്ടൽ ആരോസ് 8 ഉണ്ട്. ഇതിനകത്ത് ഇവിടെ ആദ്യത്തെ ഈ Aയും Bയും കണക്ട് ചെയ്യുന്ന ഒരു ആരോ, അപ്പൊ 1. പിന്നെ Bയും Cയും കണക്ട് ചെയ്യുന്നത് രണ്ടാമത്തെ ആരോ, അപ്പൊ 2. അപ്പൊ ടോട്ടല് 2 ആരോ. അപ്പൊ ടെസ്റ്റ് 1-ല് 2 ആരോസ് ഉണ്ട്. ഇനി ടെസ്റ്റ് 2-ല് Aയും Bയും കണക്ട് ചെയ്യുന്ന ആരോ ഇവിടെ നമ്മൾ പറഞ്ഞല്ലോ. അപ്പൊ ഇനി അത് എടുക്കണ്ട. പക്ഷെ
Okay.
ബിയും ഡിയും തമ്മിൽ കണക്ട് ചെയ്യുന്ന പറഞ്ഞിട്ടില്ല. അപ്പൊ ബി ഡി ഒരു ആരോ 1, പിന്നെ ഡി ജി അതായത് അടുത്ത ആരോ അത് 2, അപ്പൊ 1 2, പിന്നെ ജി എച്ച് അത് 3. അപ്പൊ ഇവിടെ 3 ആരോസ് പറയുന്നുണ്ട്. അപ്പൊ ഇവിടെ ബി ഡി ഡി ജി ജി എച്ച് അപ്പൊ 3 ആരോസ്. ഇതിലാണെന്നുണ്ടെങ്കിൽ എ ബി ബി സി 2 ആരോസ്. അപ്പൊ 2 + 3 അതായത് 5. ടോട്ടലി 5 എണ്ണമാണ് നമ്മൾ ഇത് ചെയ്യുന്നത്. സോറി, ടെസ്റ്റിൽ ഈ 2 ടെസ്റ്റും കൂടെ ചേർത്ത് 5 എണ്ണമാണ് നമ്മൾ ആരോസ് ആണ് കവർ ചെയ്തത്. ഡിവൈഡഡ് ബൈ ടോട്ടൽ ആരോസ് 8.
8. Okay. 5/8.
5/8. ഞാൻ ഈ ആരോസ് എന്ന് പറയുന്ന ടെസ്റ്റ് കേസ് ആ പാത്താണ് ഉദ്ദേശിക്കുന്നത് കേട്ടോ. ഞാൻ നിങ്ങൾക്ക് മനസ്സിലാവാൻ പെട്ടെന്ന് പറഞ്ഞല്ലേ ഉള്ളൂ.
Okay.
പിടികിട്ടിയല്ലോ അല്ലേ?
കിട്ടിയത്.
പിന്നെ ഈ ഫ്ലോ ചാർട്ടും അൽഗോറിതവും അത് പിടികിട്ടിയല്ലോ, എങ്ങനെ ഫ്ലോ ചാർട്ട് കണ്ടുപിടിക്കണമെന്നുള്ളത് മനസ്സിലായിരുന്നു.
നമുക്ക് ഈ ഷോർട്ട് കട്ട് പറഞ്ഞു അതൊക്കെ ആയി. അല്ലാതെ എങ്ങനെയായിരുന്നു?
അല്ലാതെ നമ്മൾ നേരത്തെ ഈ പറഞ്ഞ കണക്ക് ഇങ്ങനെ ഇതില് ബ്രാഞ്ചസ് എടുക്കണം അത് പറഞ്ഞത് പിടികിട്ടിയായിരുന്നു. മിനിമം നമ്പർ ഓഫ് പാത്ത്.
മിനിമം നമ്പർ ഓഫ് പാത്ത് രണ്ടിലും മിനിമം ആണല്ലോ കൺസിഡർ ചെയ്യുന്നത്.
രണ്ടിലും മിനിമം നമ്പർ ഓഫ് പാത്ത്. പക്ഷെ ഒന്നില് ഡിസിഷനിൽ എപ്പോഴും ഈ ആരോസിന്റെ കാര്യം കൺസിഡർ ചെയ്യണം, അതായത് ബ്രാഞ്ചസ്. മറ്റേതിലെല്ലാം ഈ ബോക്സസിന്റെ സ്റ്റേറ്റ്മെന്റിലെല്ലാം ഈ ബോക്സ് അതായത് നോഡ്, അതിൽ ഈ ബ്ലാക്ക് ബോക്സ് കാണത്തില്ല, അതാണ് കൺസിഡർ ചെയ്യേണ്ടത്.
ഇതിലാണെന്നുണ്ടെങ്കിൽ നോഡ് ഇതിപ്പോ ഡിസിഷൻ ആണ്. അപ്പൊ ആരോസ് ഗ്രീൻ
ആരോ മാത്രം കൺസിഡർ ചെയ്യണം. അപ്പൊ ഈ ആരോസ് എല്ലാം കവർ ആവണം ഇൻ മിനിമം നമ്പർ ഓഫ് പാത്ത്. അങ്ങനെ വേണം നോക്കാൻ. അപ്പൊ ഈ ആരോസ് ഇപ്പൊ ഞാൻ ഈ പാത്ത് എടുക്കുകയാണെന്നുണ്ടെങ്കിൽ ഈ ആരോസ് ഒന്നും കവർ ആവത്തില്ല. അപ്പൊ എനിക്ക് എങ്ങനെ മിനിമം പാത്തിൽ എല്ലാം കവർ ചെയ്യാന്ന് ചോദിച്ചാൽ ഇതെന്തായാലും എനിക്ക് എടുത്താലേ പറ്റത്തുള്ളൂ. പിന്നെന്ന് പറഞ്ഞാൽ ഇത് കണ്ടോ, ഇങ്ങനെ ഇത് എടുത്തിട്ട് ഇങ്ങനെ വന്ന് ഇതെടുക്കുമ്പോ ഈ 2 പ്രിന്റിന്റെ ആരോസും കൂടെ കവർ ആവും. അപ്പൊ 2 പാർട്സ്.
അല്ലേ?
പിടികിട്ടിയായിരുന്നു.
കിട്ടി.
മറ്റേതാണെന്നുണ്ടെങ്കിൽ നോട്ട്സ് ആണ് നമ്മള്. ഇത്
Black box.
എക്സാമ്പിള് നമ്മള് ഇത് നോഡ് ആകുമ്പോഴത്തേക്കും ഇതെല്ലാം കവർ ചെയ്യണം. ഈ ബ്ലാക്ക് ബ്ലാക്ക് ബോക്സുകളെല്ലാം കവർ ചെയ്യുന്ന രീതിയിൽ അങ്ങനെ വരണമെന്നുണ്ടെങ്കിൽ ഇവിടെ ഇതെല്ലാം കവർ ചെയ്യണമെങ്കിൽ ഇങ്ങനെ വരയ്ക്കാം, അല്ലെങ്കിൽ ഈ പാത്തിൽ കൂടെ പോവാം. ഈ പാത്തിൽ കൂടെ പോയാലേ ഈ പ്രിന്റ് ഒക്കെ കവർ ആവത്തുള്ളൂ. അപ്പം ഈ പാത്തിൽ കൂടെ നമ്മൾ പോകണം പ്രിന്റ് എല്ലാം കവർ ആവാൻ. അപ്പൊ അങ്ങനെയാണെങ്കിൽ അപ്പം 2 പാത്ത് ഉണ്ടെന്നുണ്ടെങ്കിൽ നമുക്ക് ഇതെല്ലാം കവർ ആവാൻ പറ്റത്തുള്ളൂ. ഇതിപ്പം വരച്ചെടുക്കാനുള്ള സമയം കിട്ടിയില്ലെന്നുണ്ടെങ്കിൽ നമുക്ക് ഈ ഷോർട്ട് കട്ട് വെച്ച് ഫൈൻഡ് ഔട്ട് ചെയ്യാം. ഇഫിന്റെ മുകളിൽ, അതായത് നമ്മളിപ്പം രണ്ടാമത്തെ ഇഫിന്റെ മുകളിൽ എൻഡ് ഇഫ് ഉണ്ടെന്നുണ്ടെങ്കിൽ അൺനെസ്റ്റഡ് ആണ്. അത് അഥവാ ഇപ്പൊ നമുക്ക് രണ്ടാമത്തെ ഇഫ്, ഈ ഇഫിന്റെ മുകളിൽ എൻഡ് ഇഫ് ഇല്ലല്ലോ, ഈ ഇഫിന്റെ മുകളിൽ ഒരു ഇഫ് അല്ലേ കിടക്കുന്നത്, അപ്പൊ അത് നെസ്റ്റഡ് ആണ്. മനസ്സിലായോ? അതാണ് നെസ്റ്റഡും അൺനെസ്റ്റഡും തമ്മിലുള്ള വ്യത്യാസം. പിന്നെ സ്റ്റേറ്റ്മെന്റ് എടുക്കുമ്പോൾ എപ്പോഴും ആലോചിക്കുക എൽസിന്റെ കൗണ്ടുകളാണ് പറയുന്നത്, മറ്റേ ഡിസിഷൻ എടുക്കുമ്പോൾ എപ്പോഴും ഇഫിന്റെ കൗണ്ടുകളാണ് പറയുന്നത്. ആ ഷോർട്ട് കട്ടിനകത്തെ ഡിസിഷനകത്ത് ഇഫിന്റെ കാര്യമാണ് പറയുന്നത്, മറ്റേത് എൽസിൻ്റെത്. സ്റ്റേറ്റ്മെന്റിനകത്ത് എൽസിൻ്റെത്. മനസ്സിലായിരുന്നല്ലോ അല്ലേ? ഇനി എന്തെങ്കിലും ഉണ്ടോ ഡൗട്ട്സ്?
ഇല്ല. ഓക്കെ. ക്വസ്റ്റ്യൻസ് നമുക്കിത് കവർ ചെയ്യാം അല്ലേ? ഇതിന്റെ എക്സാമ്പിൾ ക്വസ്റ്റ്യൻസ്
ഇതെല്ലാം ആ മെറ്റീരിയലിനകത്ത് കാണും. ക്വസ്റ്റ്യൻസ് എല്ലാം നിങ്ങൾക്ക് ഉള്ള മെറ്റീരിയലിനകത്ത് എല്ലാം പ്രൊവൈഡ് ചെയ്തേക്കും. പിന്നെ വേറെ പ്രാക്ടീസ് ക്വസ്റ്റ്യൻസും ഒക്കെ തരുമെന്ന് തോന്നുന്നു. അത് വെച്ച് നിങ്ങൾക്ക് പ്രിപ്പയർ ചെയ്യാൻ പറ്റുന്നതാണ്. നിതിന് ക്ലിയർ ആയിരുന്നല്ലോ അല്ലേ? Okay, thank you.
Thank you.
Bye.